Guys, as I promised, I'm back with this video on carrier aggregation. I try to make it short, but to cover everything about CA, it has to be this much big. In this video, we will see what is CA, what are its preconditions. We will also analyze real UE logs for CA, and then we will see impact of CA on protocol stack. So let's proceed, guys. When there is no CA, UE receives and transmits data on a single carrier. This carrier is called primary component carrier, and corresponding cell is called primary serving cell. In case of carrier aggregation, one or more component carriers are aggregated with primary component carrier in order to support wider transmission bandwidth. Remember, primary component carrier from primary serving cell always remains there. Only secondary component carriers from secondary serving cells are added or deleted. Let's see what is the role played by primary component carrier in CA. It adds or removes secondary component carriers dynamically based on measurement reports received from UE. It dynamically activates and deactivates secondary cells. It handles all the RRC and NAS procedures. It receives measurement reports and control mobility of the UE. Remember, primary cells can be changed only at the time of handover. Now, few important points about secondary component carriers. As per the latest specifications, an UE can aggregate maximum up to 5 carriers, that is, 1 primary component carrier and 4 secondary component carriers. So, maximum bandwidth that can be allocated to an UE is 100 MHz. Actual number of secondary component carriers that can be allocated to an UE depend on the UE's capability. Remember, it is not possible to configure an UE with more uplink component carriers than downlink component carriers, but reverse can be true. There are mainly 3 ways in which CA carriers can be allocated. Intra-band contiguous. In this scheme, primary component carrier and secondary component carriers are contiguous and belong to same band. As spectrum allocation to operators is not always uniform, it is not always possible to have this scheme. Intra-band non-contiguous. In this scheme, primary component carrier and secondary component carrier are allocated from same band, but they are not contiguous. Interband non-contiguous. In this scheme, primary component carrier and secondary component carriers are allocated from 2 different frequency bands. There are almost 50 LTE bands available as per latest specifications, so there will be infinite number of possible band combinations if we use all these carrier allocation schemes. To resolve this problem, 3GPP has defined all the allowed band combinations for CA. Section 5.5a of specification 36.101 has all the allowed band combinations. We can denote various band combinations using following notations. Denotes intra-band contiguous CA. It means component carrier belong to band X and all component carriers are contiguous. Denotes intra-band non-contiguous CA. It means component carriers belong to band X, but they have gap between them. Denotes interband CA. It means component carriers belong to band X and band Y. Main precondition for CA is that UE should be capable of it. UE tells its CA capability to the network at the time of registration in UE capability information message. These UE capabilities are most difficult part in understanding CA. Rest of the things about CA are very easy. Let's see what all information UE sends to network for its CA capabilities. Access stratum release. CA is a release 10 feature, so UE should be of at least release 10 for CA to take place. UE category defines a set of uplink and downlink capabilities. In release 8, only 5 UE categories were defined. In release 10, with introduction of CA, 3 more UE categories, 6, 7, and 8 were defined. Supported band combinations. As we know, 3GPP has defined all the allowed band combinations for CA. UE sends whatever band combinations it supports from these band combinations to E node B. CA bandwidth class. CA bandwidth class tells UE's carrier aggregation capability for the particular band. For example, if UE supports bandwidth class A for a particular band, it means UE can have only one contiguous carrier from that band and can get maximum up to 100 resource block from that carrier. If UE supports bandwidth class B for a particular band, it means it can have only two contiguous carriers from that band but can get maximum only up to 100 resource block from these two carriers in combined manner. Let's take some practical examples. If I say CA3C, it means this UE would be able to aggregate two contiguous carriers in frequency band 3, and it can get transmission bandwidth from 100 resource block to 200 resource block in combined manner from these two contiguous component carriers. If I say CA25A25, it means this device is able to aggregate two non-contiguous carriers in frequency band 25. Each component carrier will provide a maximum transmission bandwidth of 100 resource blocks. Few sample valid CA configurations could be: it means two non-contiguous carriers from band 25. It means one carrier from band 25 and other carrier from band 41. It means two contiguous carriers from band 23. Aggregated bandwidth between 25 resource blocks to 100 resource blocks. Two contiguous carriers from band 2. Aggregate bandwidth between 100 resource block to 200 resource blocks. One carrier from band 1 and two contiguous carriers from band 41. Remember, you will never find a CA configuration like CA25A because you need to have at least two carriers for CA. 25A means only one carrier in band 25. To understand this concept, let's consider CA configuration CA1A8A. Here, 1A means UE can have only one carrier from band 1 and can have maximum bandwidth 20 MHz from that carrier. So, there are 6 possible values of bandwidth on this carrier. Similarly, 8A means UE can have only one carrier from band 8 and can have maximum 20 MHz from that carrier. Here also, there are 6 possible values of bandwidth on this carrier. Now you can think, there could be large number of combinations of bandwidth allocation to the UE across these two bands. If we do mathematics, we get 36 possible combinations of bandwidth across these two bands for two component carriers. Therefore, 3GPP has defined all the valid bandwidth combinations for all the possible CA configurations. These tables for allowed bandwidth combinations are quite big. So, I have taken this small segment from a table to give you an idea about the bandwidth combination set. You can notice, here for this CA configuration, 3 bandwidth combination sets are defined. In bandwidth combination set 0, only 8 bandwidth combinations are possible. In set 1, only 4 bandwidth combinations are possible. In set 2, only 12 bandwidth combinations are possible. Even if UE supports all the bandwidth combination sets 0, 1 and 2, total number of possible combinations will be 24. That is much lesser than 36. So this is the purpose of defining all these combinations in the specifications. Otherwise, there would be so many possibilities. UE sends I supported bandwidth combination set in UE capability information message to tell supported bandwidth combination set for a CA configuration. Remember, if UE supports only bandwidth combination set 0 for a particular CA configuration, then UE does not send I supported bandwidth combination set for that CA configuration. Finally, I can summarize what all capability information is sent by UE to E node B for CA. Access stratum release, UE category, supported band combinations, CA bandwidth class, and bandwidth combination set. Guys, this was toughest part of the video. You might feel a bit overwhelmed with the information, I know. It happens with everybody because there is so much information to digest. Don't worry and proceed. When we will do log analysis, everything will become clear. Now let's come to the real thing, that is log analysis. UE tells its CA capabilities to the eNote B at the time of registration. UE sends message UE capability information having all the CA related capabilities to eNote B. Let's see this message from real UE logs. This UE is of release 11. Here UE has listed what all bands are supported by it. This UE supports band 1, 3, 38, 39, 40 and 41. Remember, this I is not CA specific. Even release 8 UE sends this list. UE category version 1020. Value of this I could be 6 to 8. Here our UE is of category 7. These are the supported band combinations. For each band, UE has mentioned uplink and downlink CA bandwidth classes. This combination is CA183A. It is an example of interband CA. This is CA3A3A. It is intraband non-contiguous CA. This is CA38C. This is intraband contiguous CA because CA bandwidth class C means two contiguous carriers in a band. Feature group indicator release 10. This I has got 2 bits related to CA. Bit 111 tells whether measurement A6 is supported. Bit 112 tells whether secondary cell can be added during the handover to EU-TRA procedure. Here, UE has reported all the supported bandwidth combination sets. As I told you earlier, if UE supports only bandwidth combination set 0 for a CA configuration, it will not send this I for that CA configuration. You can see only for few CA configurations, UE has sent this I. This 11 is a bit map. First bit represents bandwidth combination set 0, and second bit represents bandwidth combination set 1, and so on. Guys, if you have any doubt related to registration process, go to my another video on this topic. Measurement report. You can see here in this measurement report, UE is sending measure RSRP for 2 neighboring cells. Based on this measurement report, network will decide to add cell 199 as secondary cell. RC connection reconfiguration. Whenever eNote B wants to add some secondary cell to an UE, it sends all the secondary cell parameters to UE in this message. Here is this message from real UE logs. These are the parameters needed to configure MAC layer. Whenever secondary cell is added to the UE, eNote B will enable extended buffer status reporting and extended power headroom reporting in UE's MAC layer. Extended form has to be used for BSR and PHR reporting because now MAC layer needs to report these values for multiple cells. In coming part of the video, we will discuss about impact of CA on MAC layers in detail. At that time, we will revisit these parameters. These are physical layer parameters. UE's physical layer will also have to be configured for CA. Here is the information about secondary cell to be added. SL index is used by MAC control element to activate and deactivate CA at UE for this secondary cell. MAC control element has got 7 available bits where each bit is mapped to some secondary cell. Parameter SL index tells which bit in MAC control element will be there corresponding to this secondary cell. Currently, only up to 4 secondary cells can be aggregated, so remaining bits are there only for future use. These are secondary cell physical cell ID and downlink carrier frequency. We can divide remaining information into 2 main parts, common and dedicated. Common information is the information that is broadcast by secondary cell and that is common for all UEs. eNote B sends this secondary cell common information directly to the UE so that UE need not to decode cell broadcast information before accessing the secondary cell. Dedicated information is information specific to this UE. UE will apply all the secondary cell configuration present in RRC connection reconfiguration message. Secondary cell will be added to the UE, but it will always be in deactivated state after addition. It has to be activated by MAC layer of eNote B, then only any data transmission can take place on secondary cell. MAC control element. eNote B sends MAC control element to activate CA at UE. SL index decides which bit in this control element will be used for activating or deactivating this secondary cell. Remember, primary cell can never be deactivated. Only secondary cells can be activated and deactivated. Let's first understand how data is transmitted when there is no secondary cell. First, DCI format is transmitted on PDCCH channel in downlink, and then downlink data is transmitted on PDSCH. DCI format has information that is used by UE to decode the data present on PDSCH. Also, DCI format has scheduling ground information that is used by UE for sending data in uplink for PUSCH. Simplest configuration will be that secondary cell is transmitting its DCI format on its own PDCCH and downlink, and UE is using this DCI format to decode secondary cell's downlink data and to send data in uplink to the secondary cell. So, both primary and secondary cells are working independently. When cross-carrier scheduling is enabled, DCI format of secondary cell is transmitted on primary cell's PDCCH. Now, primary cell will have to transmit DCI format for both cells. So, it needs some mechanism to tell UE that for which cell a particular DCI format is intended. For this purpose, CIF field present in DCI format is used. CIF means carrier indicator field. So DCI format itself has got a field that tells for which cell or carrier this DCI format is intended. Now you may ask, what is the advantage of cross-carrier scheduling? See, we know PDCCH is a control channel and it is transmitted with a higher power compared to data channel PDSCH. So if an UE is receiving data from multiple secondary cells, then there could be an inter-cell interference on PDCCH. Cross-carrier scheduling is an excellent way of removing inter-cell interference on PDCCH. But remember, cross-carrier scheduling is an optional feature for UE. Cross-carrier scheduling can be enabled by RLC layer of eNote B. Here is the I that is sent by eNote B to UE to enable cross-carrier scheduling. Here, own means secondary cell will use its own PDCCH for sending DCI format, means no cross-carrier scheduling will take place, and other means UE need to decode PDCCH from some other cell to get DCI format. Remember, cross-carrier scheduling is not applicable to primary cell. Primary cell will always use its own PDCCH to send DCI format to UE. Whenever some secondary cell is added to UE, its MAC entity configures one HARC entity for that secondary cell to handle scheduling and other functionalities. BSR is used by UE to provide the information to eNote B about the amount of data available for transmission in its uplink buffers. As soon as secondary cells become active, MAC layer has to do this reporting for secondary cells also. Extended buffer size levels have been defined for CA in MAC specification to accommodate secondary cells also along with primary cell. This is the table for normal buffer level reporting, and this is the table for extended buffer level reporting. PHR is used by UE to tell difference between current transmission power level and maximum possible transmission power level. MAC layer has to do this reporting for secondary cell as soon as it is activated. This is release 8 PHR MAC control element without CA. This is updated PHR MAC control element with CA. You can see PHR MAC control element has been updated to accommodate pH information about secondary cell. Secondary cell is always in deactivated state after addition and after a handover. MAC control element is used by eNodeB to activate and deactivate the secondary cell. MAC entity maintains a timer, SL deactivation timer, per configured secondary cell and deactivates the associated secondary cell upon its expiry. This timer is used to monitor data inactivity. This timer is optional and is configured by RLC layer of eNodeB. All the data coming from multiple cells is aggregated by MAC layer and then sent to upper layers. Remember, multi-carrier nature of the physical layer is only exposed to MAC layer. All other layers such as RLC, PDCP remain unaffected. Two new PUCCH formats, Format 1B and Format 3, were defined to report HARC, ACK, or NAC for more than one component carriers. Format 1B can be used to send HARC, ACK, NAC for up to 2 component carriers, and Format 3 can be used to send HARC, ACK, NAC for up to 5 component carriers. There is one physical layer per secondary cell. The physical layer processing chain shown in this figure is repeated in UE for every uplink serving cell. Only impact at RLC layer was to have larger RLC buffer to handle data from multiple cells. That's all for today, guys. My next video will be on voice over LTE. If you have enjoyed this video, please hit the like button. Subscribe this channel for many such videos in future. See you in next video, guys. Bye bye.